Hello. In today's lecture, we're going to start Chapter 3, Describing and Exploring Data. The first section is talking about a measure of center. And by a measure of center, we mean a value that is at the center or middle of our data set. The easiest measure of center we can have is the arithmetic mean or the average. And again, we should all kind of know what an average is. It's going to be the sum of the measurements divided by the total number, right? We use X bar to be a sample population mean, and we use the Greek letter mu when it's a population mean. And we use this we call this big sigma notation. This just means the sum. This kind of big E looking thing means the sum. And that notation kind of sum or sigma of X sub I to N really just means what I'm going to do is we're going to take, kind of the first data point and add the second data point and add the third data point and add the nth or last data point and then divide it by the total number of things. So a quick example, we can find the mean of the set of data here, 29156. We would say the sample mean there is going to be the sum of my xi's divided by n. So that's 2 plus 9 plus 1 plus 5 plus 6. And I'm going to divide that by the total number of data points. There are 5 data points. So that sum is going to be 23, still dividing by 5. And I get 6.6 for my mean. The next kind of sort of obvious measure of center is what we call the median. And the median is really the middle measurement, kind of the thing right in the middle. The key is to find the median, we must rank our data from smallest to largest. And what we do is we look at the position of our data point. And the way we do that is we take 0.5 times n plus 1, where n is the number of data points. So if we were going to solve this example, I want to find the median of these set of points 2, 4, 9, 8, 6, 5, 3. First, I would have to sort the data. So the first step is really to sort it. So I'll get 2, 3, 4, 5, 6, 8, 9. There are 7 pieces of data. So the position of the median is going to be 0.5 times 7 plus 1, or 7 plus 1 is 8, so 0.5 times 8 is 4. So that means, right, this is not our median. It's not 4. The median here is the data point in the 4th position. So 1, 2, 3, 4. This is our 4th position, so our median then would be 5. And typically, the symbol we use for median is this kind of squiggly x or x tilde. We would say our median then is 5. Let's do this again. We want to find the median for this data set here, 3, 6, 1, 7, 12, 6, 23, 6, 9, and 10. Again, we're going to have to sort the data first. So if we do that, 1, 3, 6, 6, 6, 7, 9, 10, 12, 23. We need to find, well, what is the position of our median? And it's going to be 0.5 times the number of data sets. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So 10 plus 1. That's going to be 0.5 times 11, which gives us 5.5. And this is kind of different because in our first example, we had an actual 4th data point. Here, we can't have a 5.5th data point. So if we have a decimal, what we're going to do is we're going to look at the 5th and 6th piece of data, kind of the integers that surround 5.5. So 5.5 clearly falls between 5 and 6. And so our median is going to be the average of those two numbers. So the data point in this 5th position is 6. The data point in the sixth position is 7. I get 13 over 2, which is 6.5. Oh, sorry, that's not a very good 0.5. Our median is 6.5. One of the last ways to talk about the middle is mode. And mode is just going to be the most repeated piece of data, right? So here are 3 examples. If we look at this first set, 2, 4, 9, 8, 8, 5, 3, clearly we can see the mode here is going to be 8. That's the most repeated number. In this case, the second set, I have 2 copies of 2 and 2 copies of 8. This is what we call a bimodal set. There are 2 modes, so it's 2 and 8. And in this last example, every data point is unique, so there is no mode. I'm not a big fan of this. I really don't like to talk about metrics that may not exist, right? Or that may have multiple values to it. It doesn't make sense to have like multiple medians or multiple standard deviations or multiple averages. So I'm really not a big fan of having multiple modes. So we really don't kind of talk about them too much. And we might actually use the median and the mode, the median and the mean kind of together. So when might one be better than the other? One of those things is if we have what we call outliers or extreme values. The median is often used to measure the center when the distribution is kind of skewed, when we have a lot of data points kind of off to one of the sides. The mean we kind of use a lot better. The problem is it's really affected by these extremely large or extremely small values, whereas the median is not affected by how drastically large or drastically small data points are. It's just all the median cares about is that they're bigger than the middle or smaller than the middle. The mean, though, cares about the actual value. There is another kind of average that we want to talk about. It's what we call a weighted mean. So a weighted mean is used when each data point we have has an underlying varying level of importance, or what we'd call a weight. So different X data points have different weights that we call W. And we compute the weighted mean is slightly different. So this is going to be X bar sub W. And all we need to take away from this is it's going to be the sum, right, of the product of our weights and their data points divided by the sum of the weights, right? This helps kind of put an importance factor on specific data points. And these problems can be a little confusing because we're going to have 2 sets of numbers. And so a question we often get with students is, well, if I have 2 categories of numbers, which category really refers to the data points and which one refers to the weights? And the key is the data points are the question, right? So the question is going to say, find the weighted mean of body of heights, or find the mean of grade point averages, for example. So the grades themselves, those are the data points that we're going to look. The other things in the problem, that is going to be the weights. So we can look at an example. And again, a really common example is GPA, because right, every class, even though you can get an A, B, C, or D, the credits really determine how important that class is to get an A. So let's say in her first semester of college, a student took 5 courses. Her final grades, along with the number of credits, she received an A in a 3-credit class, an A in a 4-credit class, a B in a 3-credit class, a C in a 3-credit class, and an F in a 1-credit class. And if you're not familiar with how GPAs are created, an A is really worth 4 points, a B is worth 3, a C is worth 2, a D is worth 1, and then F is worth no points. So we want to find her grade point average. And so in this case, because we're looking to find her grade point average, And we said the data points are the questions. The grades that she gets are actually going to be my X's. And that makes the credits really the weights in this case. So when I look to find my weighted mean, again, it's going to be the sum of these weights times their corresponding data points divided by the sum of the weights. So when we go to add this up, I can look, that first class was worth 3 credits. So that's the weight times the grade, which is the data point, which is an A, so 4 points. The second class was worth 4 credits and had a grade of an A, which is a 4. And we can just fill in the 3 credit class she got a B in, the next 3 credit class she got a C in, and the last 1 credit class she got an F in. Divide it by, again, because my weights are the credits, down here, I'm just going to add up my weights. So 3 plus 4 plus 3 plus 3 plus 1. And if I do that, I'm going to get 43 divided by 17, and I'll get a GPA of 3.07. Hopefully this was helpful. If you have any questions, feel free to reach out. I'll talk to you next time.